let's look at 1.5 notes in your packet. It's kind of like a half sheet page for you guys. We are going to graph rational functions today. You definitely did this in Algebra 2, but you probably did it with a calculator the entire time. So we're not doing that today, okay? You will not have a calculator for any of this. So let me just kind of go through with you the basic rules, and then we'll look at some examples to make sure you understand how to use these. So your first step is factor your numerator and denominator completely. Remember how I said factoring just was never going to go away? Yeah, it's not lying to you. It's never going to go away. So we got to be able to factor. Your vertical asymptotes then come from anything in your denominator that would make it 0. And again, I'll show you all of this in an example. We also have horizontal asymptotes. Do you guys remember talking about top heavy, bottom heavy, or equal? Okay. So if the degree of the numerator is less than the degree of the denominator, that means bottom heavy. You always end up with y equals 0. Okay. If they are equal, you just divide your leading coefficients. And then the last one, if it's top heavy, meaning the degree of the numerator is greater, then you have to do division, like synthetic or long division, to find your asymptote, and that ends up being a slant asymptote. Do you guys remember what degree is, like what I'm talking about when I say degree? Someone want to tell me what degree is? The highest exponent when it's written out in standard form. Good. And then the other piece we have to look for is a hole in your graph, and that just happens if after you've factored, if a factor cancels out with both numerator and denominator. Okay? All right, so let's do this with some examples. So you can see what it looks like. I'm cheating here. I'm changing a bunch of things, so let me erase this. It's satisfying, yeah. It's nice and clean. And these little dash lines are funny. They're like yes, this is your last set of notes. Next Friday is your test. So today is the last set of notes for the unit. Then on Monday we do a fake quiz over the graphing stuff and start reviewing. Wednesday we get more review. Wednesday is your 3-hour early release though, so I think this class is like 50 minutes long, so it's a little shorter on time there, and we have to do the math space review. So we'll yes. Next Wednesday, the 19th, you get out 3 hours early. So we have 4 of them throughout the year. It's like our professional development, like we stay and do.
Oh, there's like a teacher work.
Kind of, yeah. With like stuff. Yeah. There's one on Wednesday, there's one in December on a Friday, but then you still have a full week of school before winter break. So that's interesting. There's 4 of them throughout the year. I think the first 2 are on black days and the last 2 are on red days. But it's a weird schedule too. Remember last year how on the early releases, how your lunch period always stayed long? That's not the case with the 3-hour early release. Everyone goes to lunch at the same time. I don't know how that. So grab and go lunch. So I'm assuming that means you can leave. I have no idea. I guess you're in bus.
Next Wednesday, I'm just leaving at 12.
Well, it's gonna end at like.
It's like lunch is whatever the last half hour is. It's like 11:20 or something. Yeah.
11:55.
11:55 at the end. So like from 11:25 to 11:55 is grab and go lunch for everyone.
AKA skirt it. Skirt up. Oh.
No, I mean, I think that's what's going to happen. You guys clearly can't all eat at the same time.
It would be sitting on the floor. Like, that's disgusting.
Okay, so now we're ready to grab, right? Okay, so let's look at the first example here. We're going to go through this in pieces. I'll try to color code pieces for you. So our first step we always want to do is factor, because we're going to check for holes right at the beginning. So I could factor this. Yeah, I could take out a 2, right? So I've got 2 times x plus 2 over x minus 2. Does anything cancel out there?
Yes.
No, nothing actually cancels. So, okay, great, we factored. It didn't do anything for us.
Yeah.
Okay, but that means there's no holes in our graph, so we don't have to worry about holes. Okay, the next piece we're going to worry about is vertical asymptotes. Where do the vertical asymptotes come from? All right, guys, you got to pay attention to this, otherwise it's not going to be fun. We will get to one, I think, in our next group, so I'll show you. Yeah. We'll baby step our way there. All right, vertical asymptotes, where do they come from?
Setting it out in this case would be y.
Not y equals 2, but x equals 2. Yes, it comes from what makes your denominator 0. So do you guys see how x equaling 2 would give us a 0 in the denominator? Okay. And it's a vertical asymptote, meaning up and down. So when I go to sketch that, I go to x equals 2. And there's my vertical asymptote. Okay. Next piece is the horizontal asymptote. All right, horizontal asymptote deals with the top heavy, bottom heavy, or equal. So what I want you to do is look at the highest degree term of your numerator and the highest degree term of your denominator. What do you think? Top heavy, bottom heavy, or equal? Equal. When they are equal, they're both first degree. Okay, coefficient's bigger on the top, but the exponents are the same, right? When they're equal, all you have to do is divide those leading coefficients. So I'm just taking 2 divided by 1, which is 2. So now, it's not a vertical asymptote, it's a horizontal asymptote. So instead of x equals, what do you think it's going to be?
4.
Okay, so y equals 2. That's my horizontal asymptote.
And where'd you get 2?
I divided the coefficients, or even just divide the whole term. What's 2x divided by x? Okay.
And then we get half your vertical asymptote. What's the bottom?
What makes the denominator 0? Yeah, there's too many 2's in this problem. Okay. Make sense? All right. A little bit about asymptotes. I don't know if you guys remember from last year. Vertical asymptotes, you can never touch those. You cannot cross them. Horizontal asymptotes, you can. Your graph can go all over that thing, but the ends of the graph will follow the horizontal asymptote. Okay? So let's figure out a few points on here. 2 points that we definitely want to look for to begin with are the x-intercept and the y-intercept. X-intercept and y-intercept. What can you tell me about an x-intercept?
Y is equal to
It is when y is equal to 0. So if you're looking for an ordered pair, it's something, comma, 0. And what about the y-intercept? Okay, so yeah, it's when x is 0. So this one is 0, comma, something. So So let's do our y-intercept first, because that's actually easier. If I plug a 0 into the x, and you can do it in the factored one or the original one, if these are both zeros, what am I left with? So 4 divided by -2 is, there you go. So 0, -2 is my y-intercept. I know it's towards the bottom, sorry guys. Okay, now x-intercept. I'm gonna go just so I have more room. That's just the same equation you guys have. If I'm talking about the x-intercept, meaning my y has become a 0, let's think about this. If I want this whole fraction to equal 0, which piece of the fraction needs to be 0? The numerator or the denominator? The numerator, yes, because if we have 0 divided by anything, what's it going to be? 0. So when I'm finding the x-intercept, I don't actually need to think about the denominator at all. I can just simply solve 0 equals 2x plus 4. Okay? And -2. So as far as drawing the shape of our graph, we actually have enough points over here to do this half of the graph. It's got to go through these two. Do you think it's going to be a straight line or a curve? What do you think is happening? A curve, and then what is it going to follow? The asymptote, yeah. So this one's going to approach that green line, and this side's going to approach the blue line. We still have to find another part of our graph. We have to find the right side. So we're just going to check a couple of points to see what we can come up with. The asymptote, remember, was at 2. So if I want to pick something over here, any thoughts on what you might want to pick? 3 and 4, that sounds great. So I'm going to put a 3 in, and I'm going to put a 4 in. And again, factored, original, it doesn't really matter. I'm actually going to do the original. So what's 2 times 3? Plus 4. 10 over 3 minus 2. So 10 is my answer. Okay. That does not fit nicely on my graph, but that's okay. We know it's somewhere up here, right? Pretend it's there. Okay, and then do the same thing with 4. So what's 4 times 2?
3.
Plus 4. 12, and that's over 4 minus 2, so 12 over 2, 6. So 4, 6. And then again, what is your shape going to do? Like, what's going to happen? You guys see it? It's just, you don't need like 10 points over there. I'm looking for, okay, you've got pretty much the right location and your shape is accurate. So you're going to follow your asymptotes. Okay. How are we doing so far? So the x-intercept is when y equals 0. The only way y can be 0 is if this numerator is equal to 0. Okay, so 2x plus 4 equals 0. That happens with x is -2. And then the y-intercept, you can set the whole fraction equal to 0, but you're going to make extra work for yourself.
So it works with the top.
Yeah, for a fraction to be 0, just the numerator has to be 0. Okay? And then y-intercept is when you actually plug 0 in for x. So 2 times 0 plus 4 over 0 minus 2. Okay? All right, let's try again. So clearly I've changed your second one. Turn it into that. Y equals x plus 2 over x squared plus 5x plus 6. What's our first step always need to be? Factor. So go ahead and factor for me. So we have what? X plus 2 over... Okay. Everybody okay with that? Again, if you're weak at factoring, come to me more. Okay. Careful below average factor. All right. What do you notice this time? Yes. Have a hole. These actually cancel out. So your hole then, first I'm going to rewrite this with that cancel. Do you guys see how that's a 1 over x plus 3 then? That's all that's left. Okay. Your hole, you have to tell me where it happens. So we canceled out this x plus 2. So what x value do you think your hole happens at? Negative 2, right? So what would make that 0? Okay. So the x is negative 2. How am I going to find the y value? Plug it in, and plug it into your new reduced one. It's not going to work if you plug it into the top one, okay? So I'm going to plug it in here. So what's 1 over negative 2 plus 3? 1. So you have a hole at negative 2. So I'm going to go to the graph, and I'm literally going to draw a big hole. So these factors reduced. We had the factor first, they canceled out. If a factor cancels, that creates the hole. What x value would make that factor that canceled 0? Negative 2, okay. And then we plug that negative 2 in to get the y value. All right, so then we're going to do pretty much everything we did on the last one. Where is our vertical asymptote? X equals negative 3. Remember, that comes from the denominator. And your horizontal asymptote. That's the top heavy, bottom heavy, or equal. What do you think this one is? Bottom heavy. And you can get that from the original. You can get that from your reduced. It doesn't matter. Either way, it's going to be the same for what type of horizontal asymptote. So when it's bottom heavy, what was our asymptote? Okay, y equals 0. Make sure you write those as an equation. Okay. Before I get to my little chart, I'm going to find my x-intercept and my y-intercept. And that's if they exist. You can start with the x-intercept this time. So look at my reduced fraction here. My y equals 1 over x plus 3. If I set that equal to 0, is there any way this numerator can equal 0? No. So what that means is that I don't have an x-intercept. Okay, so you just don't have one. Do I have a y-intercept? Yes. What is it? I put 0 in here.
Oh, the 0.
Yep. So I get 1/3. So 0, 1/3 is on my graph. And guys, not looking for perfection on you plotting a fraction, okay? Get it in between the right two integers, and that's all we need. 1/3 is between 0 and 1. That's actually enough if I use the hole to plot the right side of my graph to draw it, because it's going to follow the asymptote, and it almost goes through your hole. And we follow the asymptote. So that hole is on your graph. It's just an open circle on the graph. All right, so I just need a couple points to get the left side of my graph. What x values do you want to plug in? -4 and again, guys, when you're doing the points, go to that reduced fraction. It's much easier. So if I plug in -4 in, what do I get? Negative what?
-1.
Mm-hmm. So -4, -1. -5, what does that get? Sketch your shape.
What was the whole rest of the graph?
So it's as if the graph is going like right through that point -2, 1, but you're just saying, oh, we're going to make that an open circle. We haven't done domain yet, but if you had to talk about domain, like -2 is not an okay value for your domain. Okay. But the graph's going to follow that shape. So you have to make sure it's like on the graph. You can't be like, oh, my graph is here and here, and I have a hole here. Like that, it doesn't work. It's going to be somewhere along the graph. All right, what else on? Okay, I'm changing your third one. I'm changing almost all of them for you. It's okay. All right, let's do. Let's make it y equals. One over x squared minus 9. You guys want to try one?
Yes.
Ready? Okay, try. I'll help you if you get stuck. Remember, step 1 is factor. Yes. Yes, you have 2 vertical asymptotes in this one. So is it top heavy, bottom heavy, or equal? Okay, so what is the remember, write your asymptotes as equations. Vertical one is x equals. Horizontal one is y equals.
So you've got 30 figures. It is like 3% limits. So x-intercept, remember, is when y is 0. So you do it at
It does have two more classes. One of them, I should factor you. Yeah, think about it. Series idea. Difference in squares. You gotta recognize difference of squares too. I'm gonna write it up here in a second. Yeah. I believe so. There you go, guys.
I'm lost when it gets to the x-intercept and the y-intercept.
Okay, so x-intercept. A little cheat sheet up here. Okay. I want you to memorize it. I want you to just think about it and understand it. Okay, so x-intercept. I think you're on the x-axis right here. Okay. So what is which value do you know for sure you're on the x-axis? Okay, which one is 0, x or y? Okay, good. So when you do one of these, this one is fine. If this is 0, how does a fraction equal 0? Okay, this one doesn't. What if my fraction was like... So I want to set that equal to 0. Which part of the fraction really matters in making this 0? Yeah. Because it's really what you're doing. But you don't have to do that step every time. You can just say, okay, the only way this is going to work is if that numerator is equal to 0. Yeah, you're right with that. Okay?
Yeah.
All right. So, numerator. Okay. Then your y-intercept. What do we know in that case?
0.
So x is 0. That's the easy one. Just plug 0 in for x.
So is there no x-intercept?
Correct. No x-intercept, but you do have a y-intercept. Okay. We'll leave that up there. This is a big yawn. Make it. Maybe. All right, let's go through this because I think some of us are stuck in a few places. First, the factoring. All right, that is difference of squares. So if it's x squared minus 9, you're going to have an x in each parenthesis, plus and a minus, and then what's the square root of 9? So this is going to be x plus 3, x minus 3. Do you remember that now?
Yes.
Is there only holes you can cancel? Yes.
Yep, so is there anything that's going to cancel? Any x that's going to go away? So no whole, okay? All right, we do have multiple vertical asymptotes. We have one at 3 and one at -3, right? Okay. Then our horizontal asymptote. Top heavy, bottom heavy, or equal? Bottom heavy, yes. So what is my horizontal asymptote? Okay, y equals 0, right? We're all writing those as equations, right?
I've been talking. I have.
Here.
I got that part and I just passed it out.
So you're okay to hear?
Yeah.
Okay, so now I would suggest you start paying attention.
Okay.
Okay. Yes. I didn't say who you were that needed to pay attention.
I'm good.
Great.
Does it recognize voices like in the back?
It sometimes, yeah, you'll be on there. So.
Perfect.
Yeah. So I'll try not to call you out. All right, x and y intersect. So x intercept. That is when y is 0, and the only way for that to happen is for your numerator to be 0. Can that happen? No. So we do not have an x-intercept. Do we have a y-intercept? Yes. That's when x is 0, and what is y? -1/9. That's fun to plot. That's like shirt right there. Okay. All right. We have to do some plugging in because we don't have very many points on here to know what our shape is. I did. It's right there.
Oh no, I got the same spot. I just
Okay. Perfect. See, you're good. All right, let's make our chart then. So you have to look at this as having 3 sections of your graph to deal with. I'm going to start over here on the right side. So what do you want to plug in over here? 4 and 5, okay. And yes, you can do this without a calculator. All right, so 1 over 4 squared minus 9. Well, what's 4 squared? 16 minus 9? 7. You're going to end up in a very similar spot on your graph. Either way, 1 over something, right? So I'm going to say 1 over 7, which is just above the x-axis. Okay, what about when I plug a 5 in? So that's 25 minus 9. What is that? Plus 16. Our subtracting by 9 is really hard today, isn't it? A really small number is what that is, but it's positive, so I know it's up here. So what do you think that side of the graph is doing? Yeah, follow. I think it's really close. There you go. All right, in the middle, we've already done when x is 0. I would probably do like a +1 and a -1, or a +2 and a -2, to make sure you see what that shape is doing exactly. When you have 2 vertical asymptotes, usually you get either sort of a parabolic type shape, a parabola, or a cubic graph looking shape in there. We know we don't have an x-intercept, so it's not going to cross our x-axis, but let's still look and see what it's doing. So what did you guys use? Did you use a 1? Okay, so what did that give you? -1/8. So, yeah, great. Sure, that's it. What about -1? Same thing, right? So you know it's mirrored on both sides. So you're going to follow the asymptote. Again, I'm not looking for perfection there. I'm looking for your graph being generally in the right location.
I made it to a problem.
But it's down, not up. Yeah, no, because it can't cross the x-axis, right? Because we don't have an x-intercept, so it definitely doesn't go up.
Somebody else strong.
All right. And every y value you're getting out of it is negative, right? Okay. All right. Then I would want to plug in like a -4 and a -5. Because it's squared, what do you think is going to happen? Yeah, it's going to be the same as when you plugged in the positive. So this piece of the graph is going to be reflected over here as well. So you don't have to show me plugging them in. Just show me, okay, I know that is what happens. Okay? Questions on that graph? How'd you guys do? How many of you were either right or very close to right? Okay. Good. All right. Let's try one more before you get to practice a few more on your own. We haven't done any top-heavy ones, have we? So we should probably do that. All right. So let me give you... Okay. Computers were bolting. There we go. All right. All right, let's do x squared plus 3x plus 1 over x plus 1. Nope, I lied. Change that to...
That was the factor rule.
I know, it's not, and I didn't care at first, but then I realized it does matter. So let's make that -4. I don't want anything to cancel out.
Oh.
There we go. Yeah, -4 will work. Yes. Work. So let's factor it. What does your numerator factor into? Excellent. Okay. Anything canceled? Nope. So we know we don't have any holes. No holes on this one. Okay. We do have a vertical asymptote. Just one this time. Where is our vertical asymptote? At what equals? Yes, x equals -1. Good. Okay. All right. Now the exciting part of this one. Is this top heavy, bottom heavy, or equal? Top heavy. That means we have a slant asymptote this time. So it's not horizontal. It is a slant. So the way we find that is with division. So I'm going to go down below here and actually divide. I'll go back to the unfactored one. So if I've got x squared plus 3x minus 4 over x plus 1, can I do synthetic division? Yes. Would you like to do synthetic division instead of long division? Yes. So -1 out there, my coefficients are 1, 3, -4. So 1, 2, -2, -6. I'm going to just throw away the remainder because it didn't ignore the remainder. Okay, we are finding the equation of the slant asymptote, and the remainder does not impact where that asymptote is. It's not that it doesn't matter at all, but for what we're graphing, it doesn't matter. So all we care about is this, which would be x plus 2, right? That is your slant asymptote, y equals x plus 2. So I'm going to write that up here. What is that an equation of? Just a straight line, right? Do you know how to graph a line? You did at one point, I promise. Remember like slope intercept and graphing a line? Oh no, you're just laughing. That's terrible. I promise you can graph a line. Which of these am I going to start with? The 2, that's your y-intercept. So you go to your y-axis, and at 2, that's where our graph begins, our little asymptote. And then what's the slope? 1. So I am drawing this. Okay? Do you see why it's called a slant asymptote? It is slanted, yes. All right. Let me stop there for a second. How are we doing?
Just make sure. So it starts off as the y-intercept G2, and when you get the 1,
The coefficient on x, that's your slope. So up 1 over 1, up 1 over 1.
that coefficient is 3, it'd be 3 whole.
Yeah. Up 3 over 1.
And there'd be fractions that we include.
Sure, what if it's negative 1/4? What do you do?
So down.
Down 1 over 4.
Will that be in the quiz hypothetically?
Let's take quiz next time, so it's not going to matter, right?
It's gonna matter a little bit.
Matter a little bit? Matter how you feel about yourself? It's not graded. It's graded, but not in the grade book grades. We will grade it in class. So you get the feedback of whether or not you know what you're doing. Okay. We're okay with our asymptotes. Okay, what else do we need to find? X and Y intercepts, okay. So my x-intercept, that is when y equals 0. So look at this fraction. Am I maybe going to have more than one x-intercept? Yes, because look at it factored. Aren't there 2 different things that would make my numerator 0? Yes, what would they be? So negative 4, 0, and 1, 0 are your x-intercepts. Okay. All right, then we need our y-intercept. That's when x is 0. So what do I get? Negative 4. Yeah. Okay, so the shape of this, we can draw the right side. It's going to follow those asymptotes. It's going to come up the blue and then follow the green asymptote. So it's going to be over here. You guys see that? Okay, let me move it up a little for you. Okay with that? All right, then to get the left side, I already have 1 point over there, so I only need to do 1 more point. What do you want to plug in? Negative 2, negative 5, negative 3, any of those work. I'll go negative 2. And I don't care if you plug it into the original or factored this time. If I do the original, negative 2 squared is? 4, good. Negative 2 times 3? Negative 6 minus 4 plus 4, back to negative 6, over negative 2 plus 1. So negative 6 over negative 1. 6. Yes, you can write this stuff down. You don't have to do this all out loud or in your head, okay? So negative 2, 6, way up here. And hopefully that makes sense to you guys that it's going to be similar to the shape on the other side of your graph. That's it. How we doing? Okay. We're gonna make questions on this moving there. Sorry, let me move it up for you. It's hard when it's in that corner. Yeah. Yes, sorry. Sure, so y-intercept is when x is 0. So I just went to the equation and plugged 0 in for all the x's. And I got, 4 over negative 14. Okay, you're going to do a little bit of practice for me right now. So in your packet, if you turn the page, there's just a whole bunch of graphs, right? Okay, you're not going to do all of these. Let me pick a few for you to do. Let's do number 1. Let's do 5. And then we'll see where we are, okay? So 1, 5, and 8 to start with.